Okay, now I want you to connect those two dots with a straight line. It should be pretty much looking parallel to the bottom. Okay? Now, let's define what the mid-segment of a triangle is. It's a line connecting the midpoints of two sides. The mid-segment of a triangle is a line connecting the midpoints of two sides, and it is parallel to the third side. It's the definition of a mid-segment of a triangle. So to make our drawing accurate, we should throw some little parallel triangles on there. Okay? To make it even more accurate, if this is the midpoint of this side, then that piece is congruent to that piece, correct? And this piece is congruent to this piece. So that's all the information we can get from this mid-segment of a triangle thing. All right, so hey, you should know how to do this. So just for fun, take a minute to do it. You might need a calculator, you might not. And I'm going to freeze this, and we'll come back to it. And if you're not, you should ask now. No problem.
She knows.
Okay. Really, honestly, if you're not feeling comfortable with this, please see me. If you don't feel like asking right now, come and see me, because this should be pretty quick for you right now. All right, so far we've been talking about similarity. Similarity in polygons. How can you figure out if two trapezoids are similar? What do you need to know? It's one thing you know about if they are similar. What about their angles? It's like on TV when they have classrooms and like nobody says anything. My husband's like, "Is it really like that?" I'm like, "Yeah, sometimes it is." Especially when Vinny's not saying anything. So let's try that question again. Two trapezoids, one small, one big. If they're similar, what do you know about their angles? Thank you. They're congruent. Okay? One small, one big. If they're similar, what do you know about their corresponding sides? Their ratios are going to be what? Equal, right? Equal. Okay? We learned similar triangles. We figured out how to figure out if they're similar. If they have two corresponding angles, congruent, that's AA. What's another one of those letter ones that we learned to know if triangles are similar? AA and what? What? Side angle side and side side side. Okay? Well, here, we're not really proving that they're similar. We're using stuff we know about them to find unknown side lengths and such. That's what we're doing. So you have a few more theorems. I will type up a theorem sheet for your test. We were going to do that tomorrow, or today, but snow days kind of messed all that up. So, triangle proportionality theorem. Here you go. If a line parallel to one side of a triangle intersects the other two sides, then it divides the sides proportionally. Blah, 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 blah. Let's just draw a picture. Okay? Draw a picture. And then I want you to draw a line sort of like just parallel to the bottom, to this side. It's got to be parallel. So we're going to draw the little triangles. Then we're going to put letters around here. We're going to say this is A, this is D, this is B, this is C, and this is E. All right, so what this theorem says, and you're working with parallel lines. If you have two lines that are parallel, it says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So what I can say then is AD is to DB as CE is to EB. If I have these parallel lines here, I can set up this proportion. AD is to DB as CE is to EB. And I can use that to help me find unknown amounts, like an X or a Y. That's what that's saying. And this is the converse of it. If a line divides two sides of a triangle proportionally, so if this is true, then that line's parallel. That's all it's saying. And the mid-segment theorem. Draw another triangle. Just because. Pictures are good. It says the segment connecting the midpoints of two sides of a triangle is parallel to the third side, so this should be parallel. And if the bottom of this is 8, it says the segment connecting the midpoints of two sides of a triangle is parallel to the third side and half as long. So how long is this piece then? 4. Again, that's only going to be true if this is the midpoint. If these are the midpoints, it's only going to be true if those are the midpoints. So that's why you have all that there. Okay, let's use this stuff. All right, we're going to use this theorem first. If the lines are parallel, these two pieces are proportional. So notice, you've got to look at the picture and say, what do I know? Oh, look, they're parallel. They're parallel. So because of this theorem, I can say that 22 is to x. As long as I have this parallel symbol, I can use this little 22 is to x as 20 is to 10. So I started here, 22 over x is equal to 20 over 10. Because they're telling me they're parallel. And I'm going to cross multiply and divide, and x equals 11. Just a new little theorem that you're working with to find unknown amounts. All right, so here, same thing. I have parallel lines, and I have this unknown piece here. Therefore, I can use this little theorem to find out what x is. I'm going to say, doesn't matter how you set it up. You could say 4 over x or x over 4. I'll just do x over 4 equals 10 over 5. X is to 4 as 10 is to 5. Cross multiply. 40 equals 5x, and x equals 8. Okay, turn it over. This one gets a little more complicated, but it's really the same kind of thing as I told you in that 7.4 worksheet. So sometimes you have to subtract. Look what they gave us here. First of all, parallel lines. So I'm going to be working with that theorem we were just working with. I could set up a proportion that says 10 is to 14 as y is to, what?
36.
No, because 36 is the whole side length. I only want this piece, which they didn't give me, but I can write an expression. If this is 36 and this is y, what's left over here? 36 minus y. So this piece, sometimes you got to just figure out what that piece is. It's 36 minus y. You all see that? And then you can set up the proportion. You can say, okay, 10 is to 14 as y is to 36 minus y. Same thing, you just got a couple of variables in there. Doesn't matter. You have the algebra skills to figure this out. Cross multiply. 10 times 36 minus y equals 14y. $360 minus 10y equals 14y. Now what do I do? Got to get the y on one side. What should I do? Add 10y. 360 equals 24y. When you divide both sides by 24, you get, I don't remember, what is it? 15. So just know that sometimes you got to come up with this little piece here. All right, given the diagram, determine whether CD is parallel to EF. Well, I need to know if this is parallel to this. If it is, I know that this ratio is going to equal that ratio based on this theorem on the other side. So I'm just going to say, okay, well, if they're parallel, then 30 over 72 is going to equal 40 over 96. I need to see if that's a true statement. If it does equal, then I can say those lines are parallel. Now, you have options. Doesn't look like it, but what if we reduce the fraction? Y'all know how to do that on the calculator? No? Oh boy. You can't do it with those little ones back there. You can do it with a graphing calculator. But if you just really don't know how to reduce the fraction, what's another way to find out if those two are equal? Convert it to what? Decimal. Some of you are looking at me like, I don't know how to do this. Please tell me you know how to make a fraction a decimal. Do you know how to make a fraction a decimal? 30 divided by 72 is 0.42. Is that equal to 40 divided by 96, which is 42? Yes. So yes, they are parallel. Yes, they are parallel. Yes, Brooke. You could cross multiply and get the same number. Absolutely. Good thinking. She said, can I do this? 30 times 96 and find out if that's equal to 72 times 40? Absolutely. Another way to check. Or you could reduce fractions, and this is 5 over 12, which is equal to 5 over 12. There's all sorts of options you have to find out if those two fractions are equal. Okay, well let's check and see if QR is parallel to ST. Same thing, I have to check to see if the ratios are equal. 15 over 21 should equal 17 over 23. Options, cross multiply, see if the numbers are equal, reduce the fractions, put them in decimal. Either way, it doesn't matter. I'm going to reduce this fraction. This goes to this. 17 over 23 does not reduce, so they are not equal. So no, nope, not parallel. That's a parallel, it's not an 11, it's parallel. Okay, let's move on. Now, remember we talked about midpoint a little bit. Take a look at what you have here. What they're telling you is this is equal to this, which means that V is the midpoint, right? Yeah, Mrs. Burgess, Okay, this is equal to this. That means that X is also the midpoint. So I know I have a midpoint segment here. So how long is UY? How can I use that to find out how long UY is? Remember from the other side? Okay, let's turn it over and look. And this is half as long as this side. That's what it tells me right there. This is half as long as this side. So that means that UY is equal to 2 times 17. So UY is equal to 34. Okay, find the perimeter of triangle ABC. Well, first of all, I know that this is the midpoint because 3 is 3, 4 is 4. So that means BC is how long? 10? But I gotta find the perimeter, so I gotta add up all the sides. 10 plus 4 plus 4 plus 3 plus 3 equals 24. And then use the diagram to find the ratio of the perimeter of triangle ABC to the perimeter of triangle ADE. Now, we learned earlier that similar triangles, the ratio of the perimeter is the same as the ratio of the corresponding sides. I don't know if you remember that, but we did. If you have similar triangles, okay? So what we need to do is we need to draw, I'm going to draw this small one. We're going to decide if they're similar. And I'm going to draw the big one. How long is this side? 14. And this side is 18. Perhaps I have side angle side. Let me check the ratios. 9 over 18 is equal to 1/2. Okay? 7 over 14 is equal to 1/2. And I know that angle A is congruent to angle A, or, yeah. So I have side angle side. Oh, side angle side, I should put SA here, sorry. Side angle side, side angle side, side angle side ratios. So I can say, therefore, that the ratio of the perimeter is the same as the ratio of corresponding sides the ratio of the perimeter is the same as the ratio of corresponding sides, which is 1/2.